Okay, guys, hey, the best way to talk about special right triangles is that triangle that we use over and over again. And sometimes it's a 45-90. Otherwise, it's what we would call an isosceles right triangle. 45, 45, 90. The other one that we see a lot is a 30-60. Now, if you remember from our work before, the bigger the opposite side, the bigger the angle. So that's my 61 up there and my 31 down there. And we'll explain how we can use these, how these will be helpful. Okay, first of all, it says there are 45, 45, 90 triangles. So we know if that side's 4, then this side is also 4. So when we use our Pythagorean theorem to find the missing side, it would be 4 squared plus 4 squared is c squared. Well, that's 16 plus 16. Another way to think of that, it's 2 times 16 is equal to c squared. And when I take the square root of that, okay, let's stop for a minute. And when I take the square root of that, we have this. Well, the square root of 16 is 4. So we end up with that as an exact solution. So our hypotenuse is 4 square root. Okay, now we have a hypotenuse equal to 8. We mark these both x's like I've marked here. So it's x squared plus x squared is equal to 8 squared. That means 2x squared is equal to 64. And then x squared would be equal to 32. Well, from our work before, then x squared is equal to 2 times 16. And x then would be the square root of 2 times 16. Square root of 16 is 4. And that also would be 4 the square root of 2. So these sides are 4 the square root of 2. Well, there's a way of noticing what this is without looking at that. And we'll move down here a little bit. This part right here says, in a 45, 45, 90 triangle, both legs are congruent. And the length of the hypotenuse is the square root of 2 times the length of one leg. So, what do they mean? If this is x, that's x, and this is going to be x square root of 2. So if we have another triangle, we put some numbers in there. If this is 4, that's 4. That's 4 square root of 2. I no longer have to do the Pythagorean theorem. I just apply the relationship to the problem. So I got a couple more examples. Well, the hypotenuse is the one across from the 90. So one leg is 9. The other leg is 9. Therefore, 9 square root of 2 is the hypotenuse. Now, what tends to be harder is when we have something with a square root in it, like this right here. It's not too bad. There again, there's our hypotenuse. So that's the leg. The other leg is the same. And the hypotenuse is the square root of 2 times the square root of 2. Well, the square root of 2 times the square root of 2 is 2. 2 times 2 is 4. So x, that side length is 4. So find the value of x. This time it's the leg. Well, if that's x, we know that one's x as well. Well, let's see. If we multiply the leg times the square root of 2 is the hypotenuse. The leg times the square root of 2. It makes sense that we just have to divide that then to find our answer L. Well, what do we do here? 6 divided by the square root of 2 is what? It basically works this way, guys. We have something called rationalizing the denominator. Big word. Just simply means multiply it by itself. When we do that, we get 6 square root of 2 over 2. And 6 divided by 2 is 3. So we end up with 3 square root of 2. And that would be the lengths of our legs. 3 square root of 2 and the other one would also be 3 square root of 2. Now, there are some other relationships there. You might be able to figure out a shortcut of that to figure out the answer. So let's go down here and look at B. It says find the length of a leg of a triangle with a hypotenuse which is the length of 10. That's like the last problem. So that's 10. So again, the hypotenuse is equal to the leg times the square root of 2. So we take 10 is equal to the leg square root of 2. We divide that, 10 square root of 2, and we figure out what that is. Again, our work says we have to multiply top and bottom by the same thing. Well, the square root of 2 times the square root of 2 is just 2. And then you have 10 square root of 2. 10 divided by 2 is 5. Square root of 2 is my answer. So one of our legs would be 5 square root of 2. And the other one would be 5 square root of 2 as well. Okay, to find this side, use the Pythagorean theorem. Okay, we got 3 squared plus 3 square root of 3 squared equals c squared. That would be 9 plus 3 squared times the square root of 3 squared. That would be 9 plus 3 squared is 9 times 3. Well, 9 times 3 is 27. So we got 9 plus 27. 9 plus 27 is 36. These are all equal to c squared. So at this point, c is equal to the square root of 36, which is 6. So that hypotenuse is going to be 6. If we turn this around, go a little further here, short legs 2 square root of 3 squared plus 6 squared equals c squared. There again, 2 squared is 4. Square root of 3 squared is 3. 4 times 3 is 12. 6 squared is 36. 12 plus 36 makes 48. This again is equal to c squared. When we simplify this a little bit further, 48 is 16 times 3. I use 16 because that's a perfect square root. The square root of 16 is 4, and I end up with that answer this time. 4 the square root of 3. So as I look at those first two examples, it seems to me that maybe I just multiplied this side, we call the short leg, times 2. And this is a long leg relationship. We'll talk about that further in a minute. Well, if I go further, I know that if I'm doing this, I've got to subtract the long side, the hypotenuse squared, minus the short side squared. Okay? Well, again, multiplying it out, 2 times 2 is 4 times 2. That makes 8. The square root of 6 squared is 6. So 8 minus 6 is 2. And then x would be the square root of 2. So my answer is right here, just the square root of 2. Well, that looks like you multiply the short leg by 2. That also is your hypotenuse. Let's see what else we can find. So the length of the hypotenuse is twice the shorter leg, and the long leg is the square root of 3 times the longer leg. So those definitions are right here. Okay, so there again, the shorter leg is across from the 30. That makes this the longer leg. And then if I multiply that by 2, the hypotenuse is 2 times the short leg. Your longer leg again would be the square root of 3 times the short leg. We will give you those formulas. You don't need to worry about trying to memorize us at this point. Okay, so it says find the value of each variable. Let me go back for a moment. 8xy. First thing, we always find the shorter leg. The shorter leg would be equal to x. It's always that relationship, the hypotenuse equals 2 times the shorter leg. So if I got to find the short leg, I want to get SL by itself is the hypotenuse divided by 2. So 8 divided by 2 is 4. So x is 4. Now we know the longer leg is the square root of 3 times the short leg. I know what the short leg is. It's 4. So it's 4 square root of 3. And that's equal to the long leg. And I'm done. Now the important thing here is you always have to have the short leg in order to figure out the other two. Question B here. The length of the long leg in a 36 and 90 triangle is 5. I'm going to go ahead and draw this. The long leg we said was 5. Find the length of the short leg and the hypotenuse. So at first we got to find out. The long leg equals the square root of 3 times the short leg. So I'm going to divide that again. The long leg divided by the square root of 3 is the short leg. So now I do a little math. I've got 5 divided by the square root of 3. Well, if you remember what we did before, we had to multiply the bottom and top by the square root of 3. That's going to give me 3 on the bottom and 5 square root of 3 on top. That is the shorter leg. When I multiply that by 2, I simply get 10 square root of 3 over 3. And that's my final answer. And your homework or work we're going to do in class is a special right triangle worksheet. And I'll be giving that to you in a minute.